The Farm Excellence Programme at AHDB really is a project set up to demonstrate the value of implementing best practice on farms. We have 9 strategic and monitor farms located across England. It's a 4-year programme where farmers will be able to learn from industry experts, learn about the challenges and opportunities on those host farms, and hopefully go away with a lot of knowledge that they can implement on their own farms.
Hi there, we're at Scadge Hill Farm just outside Bude in Cornwall today for our Monitor Farm launch. We decided to apply, so really felt that we would hopefully be able to add something and be able to encourage other people to become engaged with AHDB.
On-farm events are so important because they provide the opportunity to come and see, to feel and sometimes even taste the information that we're talking about. We hear from lots of different industry experts, farmers, consultants, and the farmers get the opportunity to talk about what they've learnt over a cup of coffee or often a bacon sandwich.
For us, certainly, I think they're really important. You get to go and visit other people's farms, see what they're trying, see how they're able to implement changes.
Always keen to learn something, just getting information from people really, what everybody else is doing going forward.
I hope that people will come and view the farm with us, take some ideas that some of the things that we've already started to implement, but also perhaps be able to feel confident to come back and ask us a question.
And it's also a great opportunity to feed into the topics that will be discussed at further meetings and also sign up to the discussion group as well in the local area.
Okay, good evening everybody. I'll just give us just a couple of minutes just for a few more people to join. If you have already joined and there's something in particular you want from this evening's meeting, please write it in the question box and I'll do my best to make sure it's answered during this session. So like I say, we'll just wait a couple of minutes and then we'll start the webinar. What's the weather like with you, Ben?
It's not too bad. It's dry enough for once. It was very cold there last week. It was after milding up this week, so it's kind of slightly above average temperatures.
Yeah.
It's kind of ominous though, because generally when we get a good January, we're going to get a very wet February. So.
Oh no.
Yeah.
It's coming. No, it's really windy here tonight. Really windy and cold, and yeah.
We don't know what normal is anymore, though, do we? I mean, it's so unpredictable year to year.
I know.
Yeah.
That's it. Brilliant. Well, so it's 4 minutes past 7 now. So I think we'll officially start the webinar. Good evening, everybody. My name is Sarah Penrose and I work in the beef and lamb team at AHDB. Tonight's webinar is the first of a series of 3 webinars, which I run with Teagasc and also BSAS. Across all 3 webinars, we're focusing on carbon and how to reduce it in the livestock sector. Often the topic of carbon is quite confusing. There's so much information out there. But really the aim of these 3 webinars is to try and make it a little bit more clearer and bring research back down to farm level. So reducing carbon often goes hand in hand with increasing efficiency. And over the course of the 3 webinars, we hope to demonstrate that small changes in management practice on farm can actually have big impacts on carbon mitigation. So tonight's webinar is focusing on grass and forage management. The next webinar in the series is on the 7th of February, and that's focusing on fertiliser management. And then the final webinar is on the 21st of February, and that's where we'll discuss breeding and genetics. So if you feel over the course of those 3 webinars that your questions haven't been answered, or there's particular topics that we haven't discussed, please let us know in the feedback, and I will make sure we organise for covering those particular topics. So really, the idea of tonight's webinar is it's going to be very conversational. So we have some really good panellists lined up for you this evening. But all they're really going to do is give a 5 to 10 minute presentation, really to introduce the topic, and then the rest of the webinar is down to you at home to send in your questions so we can make sure they're answered. So it's probably time to tell you how you can ask questions if you don't already know. So hopefully you will have a toolbar on the right hand side of your screen. You'll see that one of the headings listed on that toolbar is a question box. If you open that question box, you'll be able to write in your question and then press send. And it's my job throughout the course of the evening to read out those questions and make sure they're answered by our panellists. If there's something that our panellists can't answer tonight, we will make sure we get the answer to you by the end of the week. So, without further ado, let's introduce our panel. So, Ben is talking to us all the way from Ireland. Do you just want to introduce yourself, Ben?
Yeah, so my name is Ben Lahart, and I'm a researcher working in Teagasc Moor Park in County Cork in Ireland, looking into ways in which we can reduce methane output. So different areas, so breeding additives, but specifically on grazing management, have an interest in that as well, and how we can use forage to reduce methane output.
Brilliant, thanks for joining us tonight. Kat, do you want to go next?
Hi everybody, so my name is Kathyrn Huson. I'm a research scientist and I work for the Agri-food and Biosciences Institute, which is based in Northern Ireland. I work on a number of different projects, all focusing on sustainable grazing systems, predominantly for dairy animals, but working with beef and sheep as well. And I also work on the Grass-fed GB project, so stepping away from Northern Ireland over the water back into GB, where I would call home, and working to monitor grass growth and quality across the country.
Brilliant. We look forward to hearing more about that later on. And Kim, if you'd like to introduce you.
Yeah, thank you. Good evening, everyone. Yeah, so I'm the head of animal breeding, Kim Matthews, head of animal breeding and product quality at AHDB, but also the current president of BSAS, at least up until our conference in March. By the way, it'd be great to see you all there if you're available. So this kind of series of webinars came out of an idea that we had to bring the 2 organisations, AHDB and BSAS, a bit closer together, and also Teagasc. And the 3 share a number of common objectives. And so this webinar series is really about bringing together the scientists with practical messages to help us to move towards reduced carbon emissions. And of course, Britain and Ireland, Britain and Ireland share a lot of attributes of climate and conditions for the production of grass and forage, which underpins the production of some great quality beef and lamb products. So I'm really looking forward to what our 2 speakers have to say this evening, and talking afterwards about how we can learn from each other and help reduce our carbon emissions.
Brilliant, thanks Kim, and thank you all very much for joining us. Ben, do you want to go first?
Yeah.
So you've got a short presentation, and then there will be a question and answer session afterwards.
Okay, just confirming you can see that okay?
Yeah, that's great. Perfect.
Okay, all right, so as I said, my name is Ben, so I'm a researcher working in Moor Park in Fermoy, and I'm just going to talk about ways in which we can reduce methane emissions through improved forage management. So I suppose the reason we're focusing on methane emissions, it makes up the majority of our greenhouse gas emissions from our agricultural sectors. So in Ireland, methane emissions from enteric fermentation, and by enteric fermentation I mean feed digestion, that makes up about 58%, just about 58% of our agricultural emissions in Ireland. And in the UK, I think the figure is close to about 50% of the agricultural emissions. In Ireland, I suppose there's been a big focus put on all our industries to reduce our emissions, across, the likes of transport, amongst the other industries, as well as agriculture. And agriculture has been set a target of a 25% reduction in total greenhouse gas emissions by the year 2030. So a fairly steep challenge ahead of us. And I suppose because methane makes up such a large proportion of our agricultural emissions, ultimately tackling it, getting better methods of understanding it and ultimately reducing it is going to help meet our climate change targets. It's going to be crucial to meet those targets. So in terms of how methane is produced, then just to give a brief overview. So I suppose it's produced as a result of ingestion and digestion of feed. So you can see an overview here. So first of all, a ruminant. So by ruminant I mean the likes of a cow, or a sheep, or a goat. Basically consumes feed. This feed goes into the rumen, into the stomach. It's broken down by bacteria through digestion and fermentation. Byproducts of this are used by the animal to either produce milk, to grow, or to, as a maintenance function, just to maintain itself. But another byproduct of this is hydrogen, so a H2, or carbon dioxide, or CO2. You can see that there. And hydrogen is actually toxic to the animal. So if it accumulates in large enough quantities, it can have a negative effect on the animal. It can stop potentially feed digestion and impair performance. What ruminants have actually evolved to do over the last thousands of years is to have methanogens, which are microorganisms within the rumen, which are able to utilize this hydrogen, or H2, combine it with carbon dioxide to form methane. So that's all well and good. It's produced, it's belched, the cow can go about doing whatever it wants to do, but it has a warming effect. It goes up into the atmosphere. So I suppose methane is mainly produced as a result of increased intake. So the more feed eaten, the more methane produced. So when we think of our different stock classes on farms across different industries, there's differences in intake. So a dairy cow will have the highest intake, and as a result of that, it will produce the most methane. Beef animal is kind of intermediate there. It'll produce an intermediate level of methane. Then a sheep, because it's the lowest level of intake, it will produce the lowest level of methane. So that's, I suppose, the reason why there's differences in methane output between different individual stock classes across the different sectors. But another thing that influences methane is the quality of the diet these animals are consuming. Higher quality diet can lead to less methane being produced. As a higher quality diet, say better quality grass, better quality silage, passes through the rumen at a faster rate, and there's actually less time for those bugs to capture that feed and to produce methane. Another thing it can do, it can actually drop the pH of the rumen, so those bugs actually don't like a high pH, or a low pH I should say, so that can inhibit methane being produced in that regard. So because higher quality diets can reduce methane output, and because we can influence diet quality, forage quality through better grassland management and grazing systems, grazing management and forage management offers a very solid foundation for us to reduce methane output on farms. So when we think of, I suppose, grazing management, we think of the profile of methane across the year. In dairy cows, what we're seeing is that there's actually a seasonal nature to the methane output of the cows. So you can see this graph in the top right-hand corner. You can see that the level of methane being produced by the cows is substantially lower in the springtime in comparison to the summer and autumn periods. I just like to confirm. Can you see that thing this grid here, or am I just seeing it? You can't see that. Yeah. That's fine. Okay. No, I can work away that. Yeah, that's fine. Yeah. So the level of methane will change across the year. So what this suggests is that getting animals out to grass earlier in the springtime, making use of this highly digestible grass, can reduce methane output. So you can see this graph here in the bottom. So this is the level of fiber in the grass. As this increases, the level of methane increases along with it. So we all know in the springtime, the grass is very leafy. There's low levels of fiber. This is leading to low levels of methane being produced. As the grazing season progresses, we all know the grass goes stemmier, it loses quality, its feed value, and as a result of that, the level of methane will increase with that. So in the summer months, the methane will increase. but this can be offset somewhat by ensuring the animals are grazing the correct cover. So by covers, I mean pre-grazing herbage mass in the mid-season. So in Irish terms, we target a cover of 1,400 to 1,600 kilograms of dry matter per hectare. I know in the UK, you're adding 1,500 on top of this, so it would be 2,900 to 3,100 kilograms dry matter per hectare. They'll ensure that the animals are grazing high quality grass in the summer months and can reduce methane output. Another benefit of higher quality grass is it'll actually increase performance. So an increased performance will mean the animal will grow at a faster rate, there'll be less days to slaughter, and there'll be lower lifetime emissions. The animal will be spending less time, actually be spending less time producing methane, so that can reduce methane in that regard, and as well as increase profit. Increased performance will increase profit to the farmer as well. So that's grazing management. Then in terms of clover, incorporating clover into the sward. So we know clover is a higher quality feed compared to perennial ryegrass. And because of this, it can increase intake and subsequently increase animal performance. Some research in sheep by Sarah Wood-Martin and Fiona McGovern in Teagasc and Rye looked at feeding sheep clover. And what they found is that feeding sheep a grass-only diet, so 100% grass compared to grass clover, which was 75% grass and 25% clover, led to about a 12% reduction in methane output from the sheep. So this is, I suppose, in line with what other studies conducted in New Zealand would have found. They found lower methane output in sheep. When you think of other stock classes, then it doesn't necessarily translate through. So there's been research done on dairy cows, and they have found an increase in methane output by feeding animals grass and white clover in comparison to grass only. And this is largely driven by an increase in intake. So there's an 8% increase in methane output, but there's a 21% increase in the intake or dry matter intake of this grass and white clover diet, which dwarfed I suppose the potential benefits of the higher quality in the clover. So that's just important to consider that, it does not always necessarily lead to reduced methane output. It can be variable depending on the type of study you're looking at and the type of stock you have as well. But one thing clover will give you is it'll actually fixate 100 kilograms of nitrogen per hectare. So it'll bring in nitrogen from the atmosphere. And because you're bringing in nitrogen from the atmosphere, you won't need to spread as much chemical nitrogen or synthetic in. And this will lead to you achieving the same forage yield, but it'll reduce the amount of nitrous oxide emissions. So nitrous oxide are another greenhouse gas emission within our sector. So as well as nitrous oxide, we also have carbon dioxide. And because you're spreading less chemical nitrogen fertilizer, you reduce nitrous oxide emissions. And you can see this graph here on the right-hand side. So this is a grass-only treatment receiving 250 kilograms of chemical N. And this is modeled data. And when you look at the grass clover treatment, which is only spreading 150 kilograms of chemical nitrogen, see there's a reduction in the total greenhouse gas emissions. And this is driven by a reduction in the nitrous oxide emissions coming from that clover system. So on average, a clover system, even if it's maybe potentially increasing methane slightly or decreasing it, it will substantially reduce your total emissions on farm, because you won't need to spread as much chemical fertilizer to grow the same level of forage yield. So that's clover. There's other interest then, so alternative forage then. So plantain and chicory are becoming increasingly popular. There's a lot of potential benefits to incorporating plantain and chicory into the sward. You can potentially see improvement in performance depending on what study you read. There's anthelmintic properties to it too. So there's lower worm burdens as well associated with the likes of plantain and chicory. But another thing then is in this study by Sarah Wood-Martin and Fiona McGovern in Teagasc and Rye as well, they found that supplementing animals with sheep with grass and plantain led to a reduction in methane output, with a small reduction in compared to grass and chicory. So there's about a 12% reduction in that grass and plantain treatment compared to, I think it was about a 5% reduction for the grass and chicory. So they can also potentially reduce methane output. Again, the results are variable. So in this study, there was a mixed sward. So in that mixed sward, it comprised of grass, clover, plantain, chicory, as well as Saliburnet was the other one. So that was the composition of this mixed species forage. This study was conducted in Germany on dairy cows. And this had a higher methane output in compared to a grass and clover treatment. So again, just highlighting that there's just more work needed to, I suppose, get a better understanding of what these actually do to methane. And as we conduct more research, we'll get a better understanding of it. We're in Teagasc, we're conducting, as you've seen, there's research done on sheep, but there's also research coming in the coming year on beef cattle as well as dairy cows as well. So it'll get a better understanding of what these swards are doing to methane output. Another thing then we can potentially put into grazing swards to lower methane output is tannin containing forage. So sandfine and bird's foot trefoil are forages with a high condensed tannin levels, and tannins can actually reduce methane output as they can inhibit the bugs in the rumen, the methanogens, and they can also, they can also change the digestive patterns going on in the rumen. So this can potentially reduce the methane output. And there's actually a lot of work done in New Zealand in the late 90s, early 2000s, looking at the likes of these forages, feeding them to animals, and they've seen reductions in methane output. But a big one of the things they found was that the agronomic potential, or I suppose the grazing characteristics, yield, and the persistency of these forages in the swards weren't as, I suppose, as good as like the likes of perennial ryegrass or white clover. So they haven't been taken up in that regard. But there's been research started in Teagasc looking at these compounds and looking at the grazing characteristics of them, as their benefits are obsolete without adequate agronomic performance. So they need to be able to yield similar to a perennial ryegrass and white clover, and have sufficient persistence. There's no point in them reducing methane output for a grazing season if they're not going to be there the following year. So we're looking at this in this regard. So to conclude then, improved forage quality through better grazing management can reduce methane output on farm. As well as reducing methane output, it will also reduce your total, can potentially reduce your total carbon emissions and improve profitability on farm as well. Clover's impact on methane is variable depending on what study you look at, what's the type of ruminant actually is in the study, but it can reduce total system emissions substantially because you won't need to spread as much chemical nitrogen. And then just finally, further work is required to understand the impact of alternative forage species on methane output, the likes of plantain and chicory. I suppose so we can give a more conclusive understanding of what they're actually going to do to methane output, and as well as total carbon emissions on farm. So that's the end of the presentation. If anyone has any questions, you can ask away.
Thanks, Ben. So we have quite a few questions come in actually, which is great. Please do keep sending your questions in. So there's a couple that are kind of along the same lines. So would the increased intake and therefore increased methane for dairy cows, I think it was with the clover and the mixed forages,
yeah,
would this be negated by reduced supplementation, or do you see an increase in yield from grass clover and therefore similar emissions per litre? So I suppose what was the performance of those cows?
Yeah, so what they found was they had a higher intake, higher milk solid yield or milk yield, but there wasn't any. There was no, I suppose we call it dilution. There was no the amount of methane produced per unit of product or milk production wasn't reduced in the clover. So it wasn't there wasn't a benefit in that regard in terms of the efficiency from the dairy side. The sheep studies then generally they reported related to intake, and they don't really report performance like daily gain or anything. So they just look solely at intake.
Yeah, so the dairy cows, they may produce more milk, but
it didn't lead to a reduction in, it didn't lead to an improvement in efficiency, I should say.
Yeah.
But that total system study, so I shown the total carbon emission study, that study seen a reduction in total carbon emissions per unit of fat and protein corrected milk. So although it mightn't necessarily reduce it per cow, just say in a grazing paddock, you consider the whole farm system, the research has shown that it will reduce total carbon emissions per hectare and total carbon emissions per unit of fat and protein corrected milk.
Brilliant, thank you. Right, where should I go for the next one? Were the results from the Teagasc studies on methane output for different forage species statistically significant or anecdotal?
They were statistically significant, yeah. So those, the perennial ryegrass, so that was, what I showed there was the clover study, that was significantly lower, yes, than the grass only. And then all the other treatments, so the plantain and chicory or plantain and grass and the chicory and grass was significantly lower, yes, compared to the perennial ryegrass. It wasn't anecdotal, it was significant.
Brilliant, brilliant. I think we must have some academics listening in tonight. So another question, does the methane reduction mean that the ruminants, sorry, my screen's just moved up. Where was that? Does the methane reduction mean that the ruminant will have more H2 that they can't get rid of?
Yeah, potentially that's one of the ways. So one of the things that it depends on the mode of action. So like just say spring grass, what I showed had lower levels of fiber, and lower levels of fiber can potentially inhibit, can lead to a change in it's called volatile fatty acid profile in the rumen. So there's acetate, propionate and butyrate, and an increase in propionate, which is associated with lower levels of fiber, can actually pull hydrogen away. So yeah, that's one way. So that in that way, it would actually potentially lead to lower levels of hydrogen within the rumen. And then there's other ways as well. So it will reduce pH. Lower levels of fiber can potentially reduce pH, which directly inhibits the methanogens as well. So if there's no methanogens there, that can potentially lead to an increase in hydrogen. So whatever reduction you're seeing from one way could potentially be increased the other way, and there might be actually any impact on absolute hydrogen, but the total methane would be lower.
Okay, brilliant. So where should we go? So we'll go to this one. Are we sure that nitrous oxide emissions from fertilizer use is less than from clover use if they both input the same amount of nitrogen to the plant or soil system?
So it's associated with, I suppose, the clover. The thing about clover is it will, so it's spreading of the fertilizer. That's what it's associated with, the nitrous oxide emissions.
Okay.
It's coming it's not necessarily the most of it from the clover. Now I could stand correct from this. It's not my specific area, the absolute carbon footprint, but it's mainly from the urine patches associated with the clover, which wouldn't be as great as the amount of nitrous oxide associated with the actual spreading of the synthetic fertilizer.
Yeah.
So majority of you're getting roughly 80 to 100 kilos of nitrogen coming in from the atmosphere and being fixated by the nodules on the clover plant. So that wouldn't, or by rhizobium bacteria from the clover. And that wouldn't necessarily lead to, that doesn't have any nitrous oxide emissions associated with that process.
Yeah. So this is a really interesting question. I look forward to hearing your answer. So at last week's British Cattle Breeders Conference, someone from Nottingham Uni suggested that housing dairy cows could significantly lower methane because grass quality is so variable on a grazing system. Therefore, should we be housing or grazing our dairy cows?
I know there's a study conducted in Wageningen University, and their conclusion is actually to go put cows out grazing, because they're finding that compared to indoor systems, they did a study in 2020 and they looked at feeding an indoor diet versus a grazing diet, and this found substantially lower methane in grazing, especially in the spring period. So spring grass essentially is nearly a natural feed additive in itself, in that it will substantially reduce methane output. But the grass has to be managed correctly. If it's managed poorly, you will get an increase in methane output. But it's like anything, an indoor system where feed is managed poorly, you're going to get an increase in methane output as well. It's all down to how you actually manage the feed. A good quality grass versus an indoor diet look, it depends on the level of concentrate in the diet and stuff like that. But generally, what finding that grass is that methane is lower, and you can reduce methane output by grazing good quality grass in comparison to an indoor diet.
Yeah, brilliant. So in terms of greenhouse gas and carbon dioxide equivalent, grazing grasses of higher quality reduces methane production. But is there a trade-off with the grass ability to pump carbon into the soil, because the percentage of root mass is significantly reduced when grazed down to a lower residual? That's an interesting question.
That is an interesting question, and to be honest with you, that isn't that's not my area of, I suppose, knowledge. So I will get, there'll be more people who have a better knowledge base than that in Teagasc in terms of carbon sequestration of soils and the dynamics of it. So it would be wrong for me to answer that question without the full.
That's very honest of you, Ben. That's very honest. Kat, with you coming on camera, do you have the answer?
I do not have the answer. I don't think there is the answer. I think it's an excellent question. But I'd certainly say that the data that I've been reading it's not my area of research expertise, but just sort of reading around the literature, the picture is still quite mixed in terms of what the soil carbon dynamics are in relation to grazing management systems. There's a lot of comparisons between sort of rangeland extensive grazing systems and farmed agricultural systems, but within that breadth of agricultural systems, how different management affects soil carbon stocks is still not completely clear. And I would just say with some of the data that we've had in, we've got farms that are doing excellent grazing management, best practice, targeting sort of the residuals that Ben and myself in a minute will talk about, and their soil carbon and other soil sort of nutrient profiles and everything are bang on where you would hope for them to be. So I don't think it's necessarily detrimental, but it's a more complicated picture than just giving a simple answer to that.
Yeah. Okay. No, that's great. And Ben, I was going to say if there's anybody at Teagasc that has any
just one comment is there's a large network of carbon flux towers, eddy covariance towers, which measure I suppose whether a soil is sequestering or emitting carbon, or losing carbon, I should say. They've been put in place for the last 2 years, so they're put on different management types. I put it across multi-species swards, grass clover, grass only, and then different farm management, farms with different management. So as that data comes in place, then I suppose that question, it'll be able to answer that question clearer. But there's just been a lot of data been collected just in that regard in Teagasc, and I suppose it'll take just a few years to get a clear picture of what the data says.
That's it. It's still quite unknown, isn't it, this topic?
Yeah.
But we're getting there. We are getting there. So the final question then, before Kat, I ask you just to talk about grass check, is asking about size of animal.
Yeah.
So does a bigger animal, bigger calf, cow, mature cow size or what have you, does that impact the amount of methane produced? And then kind of a question on from that is that then influencing the size of animals in Ireland?
So the size of an animal does impact methane. So as I said, an animal who's consuming more grass, more feed, whatever, silage, whatever, is going to eat more, and there's going to be more material available there for those microorganisms to ferment and produce. So a heavier animal is going to have a higher maintenance requirement. It's going to need to eat more, so it's going to produce more methane. So weight is associated with methane. And in terms of Ireland, there's actually been a breeding index launched within our selection index. So we use the economic breeding index to select animals, and there's been a carbon trait put into it. It's called the carbon subindex, and it's putting weight on different traits. So like one of them, say, is fertility. So a more fertile cow is going to have less replacements mean less methane. But another trait is actually putting increased emphasis on maintenance, so selecting for a lighter cow. So that's indirectly selecting for lower methane output. So weight does have an impact on on animal selection in Ireland at present, because it's in relation to methane. Yeah.
Well, and I think we'll be hearing a lot more about that index on the 21st of February.
Yeah.
Colleagues are going to come and tell us about it. So that'll be another really interesting webinar. So I think somebody's just sent in a really lovely quote, which I do think just summarises exactly what you've said, Ben. So spring grass is like a natural methane reducing feed additive, which I thought was really good, really good. Yeah. Okay, thanks, Ben. I'll let you catch your breath. So Kat is now just going to talk to us about grass check. So Ben's talked a lot about the importance of grass quality, and Kat's just going to show us what the data is showing us and how what our grass is looking like. Once Kat's finished presenting, we'll then have another question and answer session. So please do keep sending your brilliant questions in. Thanks, Kat.
Have my slides come up okay?
They have, yes.
Yeah, so I just wanted to give everybody just a very brief overview of the Grass Check GB project and some of the data that we're working with. I do want to keep it brief tonight, but if anything isn't clear, please do pop your questions into the question box. And if you just want some more detail on the project, if it's something that you haven't come across yet, you can check out the project website, which is grasscheckgb.co.uk. And this is a collaborative project, so there's a number of sponsors and collaborators involved, and the logos are on the slides throughout. I'm not going to name everybody, but just to say that we're really appreciative for the great network that we're working with as part of Grass Check GB. So this project was set up in 2019, and we have a network of 50 instrumented farms set across Great Britain with the aim of monitoring grass growth and grass quality. All of the farms involved in the project operate rotational grazing systems, so they're regularly going out with a plate meter and measuring their grass and sending in samples for grass quality analysis as well. And within this project, we have a variety of farm systems incorporated, so that we're looking at sort of the diversity of grassland agriculture in GB, I suppose. So we've got organic farms, more conventionally higher input farms in very upland and very lowland, highly productive positions as well. So we are capturing farms with a range of grass growth potentials, but all working to optimise their forage management and make the most efficient use of grass that they can. Another key aim for this project, and it's slightly to the side of the carbon angle, but just something I wanted to touch on tonight, was that we had an aim to adapt the Northern Ireland grass growth forecasting model for Great Britain. So that model has been in use in Northern Ireland since I think about 2005, producing short-term grass growth forecasts during the grazing season. And it's something we wanted to develop for GB so that we can better support short-term feed budgets and planning on farms. So over the last 4 years, we've had 4 very different seasons, and the sort of conditions experienced through each of these years have really impacted on the yields that we've recorded. I've put on my slide here typical with a question mark, and I think Kim alluded to it in a bit of the discussion right at the start of the webinar. So we don't really know what a typical grass growth season is anymore. There's a huge amount of variation in the data that's coming in, and it really is weather and climate conditions that are driving this variability. With each of our instrumented farms, we have on-farm weather stations so that we can directly tie the weather and climate conditions at the same point of grass quality and grass growth rate, which is really helping to improve our understanding of these relationships. Looking at grass production, you can see the average annual yields we've recorded across Grass Check GB farms on the graph here, and they range from about 8 tonne to over 12 tonne of dry matter per hectare per year on beef, sheep and on dairy farms. And some of the work that was done at AHDB by colleagues back in 2016 estimated that the typical sort of utilisable grass yields produced on farms in Northern Ireland were around 4.5 tonne on beef and sheep farms and 7.5 tonne on dairy farms. And these estimations sort of tie in with figures that would come from AHDB and some of their Better Returns Programme publications as well. So really showing that Grass Check GB farms, that along with other farms that are implementing this measure to manage approach to their grazing systems and really following the best practice recommendations, they're achieving almost double the yields of the industry average, which is great for us to see as a project. Additionally, when we look at continuous grazing systems, it would be estimated that farms or the stock are only utilising about 50 to 60% of the grass that's available, whereas we've got the utilisation data coming in through the Grass-Track GB project, and over the past 4 years we've seen utilisation rates averaging sort of 78 to 81% across all of the farms involved in the network, so certainly much higher than those average figures. And sort of from Grass-Track GB, but also from other studies that have done, we know that the measure to manage approach and working with data coming from your grazing platform to really optimise the practices that you're employing is associated both with higher grass yields, but also higher utilisation rates and just greater overall systems efficiency. And to try and put just a little bit of a figure on that, the study that was done back in 2016 in Northern Ireland estimated that for every tonne of extra grass dry matter that's utilised on farms, the value sort of profit over margin was between £204 and £334 per hectare. Those figures are probably a little bit out of date now, I appreciate that. But when I looked at the AHDB relative feed value calculator just for the peak of this grazing season back in 2022, the current grain and protein prices compared to the value of grazed grass, you can see that May this year, with the volatility of feed prices, the value of grazed grass came in over £350 per tonne, and on a 5-year average basis it was still nearly £200 per tonne, so really valuable feed. And when we're working, as Ben's described, to improve the efficiency of forage production and utilisation, I think actually we can expect that to have a positive influence on the overall greenhouse gas emissions footprint of livestock systems. So Ben's already sort of alluded to the importance of maintaining forage quality for reducing greenhouse gas emissions. And I just wanted to highlight on this slide the quality of grass that is achievable in GB from well-managed grazing. Some figures on typical sort of on-farm grass growth quality would range from 8.5 to 11.5 megajoules per kilogram of dry matter, and that's a metabolizable energy value. The data coming in over the past 4 years on Grass-Track GB farms, we've actually seen whole season average for grass quality of over 11 megajoules per kilogram dry matter. So between the period of March and October, average grass quality didn't drop below 11. As I think Ben highlighted as well, we do tend to see a seasonal decline in grass quality. That is inevitable. It relates to changes in plant physiology as we go through the season, and weather can have a significant impact on that as well. So I've just popped this graph up showing the figures from 2022, whereas usually sort of the past 3 years of data, the orange line that represents ME, we would have seen sort of a slight decline towards the autumn time, whereas last year we did see a big dip in July and August and into September, just where the impact of the summer drought really affected grass quality. But even though there's nothing that we can do to control the weather, unfortunately, be it typical seasonal decline or the impact of difficult weather conditions, we can minimise those with good management, and the key to that is managing your pre and post grazing residuals. So we're looking at targeting grazing at the 3-leaf stage so that all of the material that's being ingested is of the highest quality possible. Once grass is maturing and you've got your dying 4th leaf coming into the sward, quality does start to drop. And if you let covers get higher and stemmier, you do increase the proportion of indigestible fibres, so that reduces the ME and the digestibility of grass and impacts on the efficiency in terms of nutritional supply, and leads to a higher rate of methane emissions from the animal as well. So we'd be targeting pre-grazing residual in UK terms, around 3,000 kilograms dry matter per hectare as a cover value, and then looking to take stock out at around 1,500 kilograms of dry matter as a post-grazing residual. And that residual is not only to make sure that the stock is eating the leafiest proportion of the stem, but also you don't want to overgraze swards, because I think that's when you do expose the soil to the potential of degradation. And if you're grazing too low down and leaving too little of a residual, then actually it does limit the rate of sward regrowth as well. Just to quickly wrap up on my slides, I did want to touch on the modelling work, just to show everybody the kind of results we've been getting so far. We're publishing 7 and 14-day grass growth forecasts in our weekly bulletins. We started last year, and that will be continuing this year. And the images on the graphs here are regional models with the actual farm data we've recorded in the blue lines and the modelled data in the red lines. Now, I know this doesn't link directly to carbon management in terms of the short-term forecasting, but just a note to say that we're working with this model, and through the work that we're doing with part of GB and other projects, we're hoping to be able to do some more detailed modelling, looking at predicting the climate change impact on UK grassland in longer-term forecasting efforts as well. But for this model, for me, I was actually really pleased to see these figures. We're not going to get a model that ever exactly matches the farm data. It's not fair to expect models to do that. There's simply too much complexity in grassland systems that we're not able to model and account for in this kind of work. But in the instance where you'd be looking at these models and these forecasts as a decision support tool on farm, we can see that the models are following the trends in grass growth that we're recording coming in through our monitoring farms and grass check GB. So hopefully those figures can be used to guide some of the short-term grassland management decisions, particularly when perhaps the weather is throwing something a little bit more unusual and unpleasant at us, and requires a bit of deviation from perhaps what we would typically hope to be doing in terms of management, so be that delaying silage cuts because there's a drought on the cards, or anything similar like that. But that was it from me for bulk on my slides.
Thanks, Cara. That's great. So we've just got a couple of questions. Somebody just asked, whilst you've got your slides up, could you clarify what you meant by percentage utilisation? I think a couple of slides earlier.
Yeah, so it's on here. So percentage utilisation is when, so we calculate this by, we look at the pre-grazing cover of stock going into the field. So for example, if that was 3,000 kilograms dry matter per hectare, and then the target post-grazing residual for that farm, if it was 1,500, then if we measured the post-grazing residual as stock came out, and this is all measurements with a plate meter, 100% utilisation would be grazing down and getting a reading of 1,500 kilograms dry matter per hectare as your post-grazing residual. So 80% would be, you're testing my maths on an evening. I don't think I can do it on the spot, but so 1,650 would be, you know, a good residual, not quite as low as you'd have hoped for. That's how we're calculating that. And for the grass check GB farms, we do work on sort of a standard target of that 1,500 as the post-grazing residual.
Brilliant. Thank you. Thank you. No, so we've got some really good questions. So I'll open this up to both Ben, Kat and Kim. So let's go with, are the rules any different for different species of grass? So I think those residual levels and grazing it down and whatnot. So they're looking for the 3-leaf stage for Timothy, Cocksfoot and Fescues.
Of course you start with a question that I don't actually completely know the answer to. I think for grasses, it's going to, I mean, please somebody else butt in if you know better than me. I'm guessing this was sort of aimed at me. For grasses, you are looking at grazing them at their leafiest stage, regardless of the variety. That's when they're going to be their most nutritious. And you can look at sort of differences between individual species and individual varieties if you go to the recommended lists documentation. it gets a bit more difficult when we start talking about multi-species swards, because they do, again, the leafiest material is going to be the most nutritious, but the heights at which you're going to be grazing those vary with each individual species. And in terms of giving cover values, we don't have validated equations for most of these species on plate meters at the moment. And it's all a bit of a work in progress to define exact what we would recommend as best practice for managing those. But certainly quality-wise, from the work that we've done in AFB, we can get excellent quality from these multi-species swards. It's just manage them requires a bit of working out at the moment.
It seems to me from what you've both said, there are a lot of questions still about multi-species swards that need to be answered. And I was thinking when Ben was talking that when you were talking about the whole farm system, that some of those species like the plantains or chicories that have deep roots might actually do you well in dry conditions. Maybe you don't have those dry conditions where you are, Ben, but we do in parts of England. We have some dry conditions from time to time, and maybe that reduces the reliance on bought-in feed at those particular times. So then you've got that whole farm equation coming in again there.
Yeah, there's been some research in Johnstown Castle in Ireland in Teagasc showing that they are to do better than the likes of perennial ryegrass in drought conditions, multi-species swards.
Certainly, anecdotally, speaking to a couple of grass GB farmers, they have grass paddocks and they have multi-species paddocks, and they have seen that helping. Although I was speaking to somebody the other week who's got very shallow soils, so I'm not sure what we can recommend.
Oh dear. And just actually on this question, another question's come in. Are the target covers and residuals that have been discussed applicable for cattle, sheep, or both?
So for sheep, I think you could be grazing a little bit shorter on your post-grazing residual. But I wouldn't suggest maybe going lower than 1200-ish. You don't want to go too short with them and scalp the grass too much. You want to leave some green in the paddock when you're bringing stock out. And I know in the middle of 2022 that was almost an impossibility. But in better conditions, you want to make sure you're still leaving a bit of green behind. With cattle, certainly with dairy animals, you might want to have a higher post-grazing residual, because there's fair evidence that when you start to push cows to maybe graze below about 1800, 1700 kilograms, you can see a drop in performance. So it depends on your individual herd, your individual farm. That is quite a flexible thing depending on what suits your system. And with sheep, you could also be going into covers more around 2,500, 3.
Okay, brilliant. Ben, I think this is probably one for you on mob grazing and tall grass grazing. Have you done any research on that? Because obviously the grass quality will differ, I can imagine.
There hasn't been any, no, not in Teagasc anyway. There has been stuff done in Europe, but I'm not fully up to date with the I can look it up anyway and get back to them.
That'd be great, thank you. Back to you, Kat, another one on grass check. So could grass check show data that isn't collated, i.e. dairy and red meat separated, organic versus non-organic, upland versus lowland, and could data be collected for longer in the shoulder seasons on beef and sheep units until pasture growth stops to give us total annual production?
Yeah, so I've got lots of data and I can break it down in lots of different ways. So I've just tried to keep the graphs quite simple this evening. We can break it down by different, I think it's broken down by production system. I can break it down by regional system within region. I have got some data split by organic, and obviously we do have that information, so that could be done. In terms of monitoring through the extending the grazing season is, I think, a win-win for your farm costs and for your carbon footprint, because typically, I know there was talk of that study in Nottingham, but typically housing is associated with higher emissions footprints. And we do encourage all of the farmers in the project to measure if they're grazing, if they're going to be grazing, if they can, to keep measuring. But for us to have enough of a bulk of a data set to be publishing and focusing on the March to October period, but we do have, if people are out measuring this week in January because they've got grass to graze, we will be collecting that data as well.
Brilliant, brilliant. So this is a quite practical question. When store cattle are out on rocket fuel grasses and the dung is really loose, does this have an impact on growth rates? So is it passing through the rumen too quickly, or are you better having a slightly like brown to grass ratio to firm the dung up? So that's quite a practical question. Ben or Kat, I don't know who wants to take that.
I just know from dairy cows, sometimes in the springtime you can have, runny dung. Just could indicate there could be a slight drop in rumen pH, but doesn't have any negative impact on the health of the cow as such. Like, there's been still performing well. They just have a slightly, it just caused, as I say, it's passed through slightly faster, but there's no evidence to say that it's detrimental to the health. A grassy young stock, I wouldn't be full up to speed on that now.
Yeah, I mean, it's something I'd like to maybe check and get back to you on, but I would say that, measuring grass is important, measuring your animal performance is important as well. So if it's just that the grass is quite rich and is running through them quite quickly and you're hitting your daily gain targets, it's not something to be particularly worried about. But with young stock in the springtime, with that kind of output into the paddock, you'd want to be making sure that you're up to date on your feed leg counts and that kind of, looking at not just looking at the grass, but looking at the whole picture of the animal and your herd or your flock, and just making sure that everything is accounted for. And then if it is purely down to the grass, you could look at putting some additional fibre into the diet.
Yeah, brilliant. And then a question from earlier that was actually quite interesting. Do higher energy silages have the same impact in winter on reducing methane output?
So higher quality silage we actually did the trial done in Teagasc feeding dry cows, and non-lactating cows poor or good quality silage. So in the good quality silage, they ate more of it, produce more methane, but to produce less methane per kilo of intake. And similar holds for milking cows, or just say growing cattle. Say you could generally tend to increase methane output, but to improve efficiency. So you'll produce less kilos of live weight gain per kilo of methane, or less milk per kilo of less methane per kilo of milk, I should say. So that's generally the trend in terms of improved forage quality indoors. At grass, as I say, better quality grass tends to reduce methane. So there's kind of some things we kind of need a better understanding of why that's occurring. And there's some indications even that grazing itself has a lower methane output compared to, say, zero grazing grass. So I know even they did this just said Netherlands, was a study where they actually carry grass into the animals, and they actually had a higher methane output compared to the grazing. So when you think about grazing, because you think about grazing, like the animals are actually able to select what they're eating, whereas you're carrying something into them, you're putting it in front of them, and they're consuming all that. So that could be one of the things that's going on there, but that's just some research that's been done. One study that was done in the Netherlands.
Wow.
That's intriguing.
It is.
Yeah, I guess that Ben, you need to look at the whole system again. So where you've got a higher quality forage indoors and they're growing faster, then
exactly,
I guess then the lifetime methane emissions might not be greater.
No. Yeah, exactly. So although on the day, maybe if you're feeding an animal higher quality silage, it could produce more methane, just say today, but on average over its lifetime, it'll spend less time getting to that target weight. So that's less days producing that methane. So on average, as you say, it'll
Wow.
Reduce it.
Wow. That's fascinating. So I think we'll make this the final question, as we're now at 8 o'clock, but this is all for you, Kat.
We have another guest.
Yeah, he knows how to open the door. I did feed him, I promise.
Oh, brilliant. From the research is really great. Just wondering how this information is being cascaded to farms and the kind of management changes that are being seen nationally. I suppose this is for both of you, really.
Yeah, I think so. With Grass Check GB, we are present on social media. We are now COVID is behind us, or at least on the back burner a little bit. We're trying to attend more of the sort of on-farm events and just help to encourage people, if you're thinking about making changes to your grazing management, thinking about stepping into the paddock grazing and looking at residuals and trying to improve quality and trying to improve efficiency. We've got a whole host of articles on our website that are features with farmers involved in the project, and where we are trying to get the message out there. But I think now that we are a bit more settled, it's something we want to do more of, and hopefully doing events like this. And
yeah, definitely. And just Ben, from your point of view, you know, with the research you're doing it.
So, like, I suppose the big thing is when we think about how you count emissions, you need a link to link, say, forage quality, grass quality up to some database to be able to translate through, say, you know, we can all know, like in a research scenario, that feeding better quality diets can reduce methane output or whatever, but you have to be able to link that through to a database to get credit, say, in an inventory, to say, like, you know, if say feed additive, you can say we're feeding this much tons or million tons of additive, this is reducing methane output, but you need to be able to quantify or measure how is the grass quality, how is silage quality on farm. So I think that's the big challenge, to actually make the link between the quality on farm to some sort of a database, and to know what that's doing to methane output. So in relation to that, we're building the database from research to make the link between grass or forage quality and methane. But the other thing we need to do is to be able to get that quality information on farms. So I think that's the big challenge.
Yeah, brilliant. And I think that's a nice place to end. Kim, did you have a final?
No, I just thank you both very much, and I think that's been really interesting. It just shows that there are things we can do. Forage, we've just covered one topic this evening, and of course there are many different things, and it's you know, if we're going to get to net zero, which we're kind of challenged with as a sector, then all these pieces need to add up to do that.
Yeah. No, that's it, and it's so important as an industry. You know, we work together and we do keep communicating, because we will find a solution. So it's now past 8 o'clock, so I'm not doing a very good job. So I will bring the webinar to a close. I'd just like to say a huge thank you to our speakers this evening, so Ben, Kat and Kim, for your input. Hopefully we have answered the majority of your questions and hopefully lifted the fog a little bit on this quite confusing topic. I think, as Kim said, you know, really tonight has highlighted how important it is to ensure we're getting that good grass quality. I think it's fair to say there's still some unknowns, and academics like Ben and Kat are working hard to get us those answers. So when the webinar ends, you will be asked to provide some feedback. Please do that. It's really important we get that, so we know that these webinars are what you want, or if there's particular topics that you want us to cover, please do put it on that feedback form. You can also get in touch with me directly, so my email address is sarah.penrose@ahdb.org.uk. So if you've got any feedback or any questions that you want answering at the next webinars, please do get in touch with me. Finally, please also make sure you register for the next carbon webinars if you want to. Unfortunately, you won't be automatically registered for the others if you've registered for tonight. So please just nip onto the AHDB website and register there. So thank you all very much for listening, for contributing with your questions, and I hope to see you at the next webinar on the 7th of February. Thanks ever so much.
Thank you.
Thank you. Bye bye.